Welcome to qnawire.
So we're told that the bird flies in the xy plane, and we're given the velocity vector v, which is equal to alpha minus beta times time squared in the x direction, plus gamma times time in the y direction. And then it gives us the values for alpha, beta, and gamma, which I wrote here. In the positive y direction, it is upwards right here, vertically. So at t equals 0, the bird is at the origin. So since t is equal to 0 at the origin, that also means that v of x initial is 0 and v of y initial is 0 here. Okay, so for part A, calculate the position and acceleration vectors of the bird as a function of time. So let's first find the position vector x, which is going to be the integral of v of x with respect to time. So this is going to be the integral of alpha minus beta times time squared with respect to time, which is equal to alpha times time minus 1/3 beta times time to the third. We can box that in as part of our solution for part A. Now we need to find the y part of the vector. This is going to be the integral of v of y with respect to time. V of y is equal to gamma times time, so this integral is going to be 1/2 gamma times time squared. We can box that in as the second part. Both of those make up the position vector, the x part and the y part. Now we need to find the acceleration in the x direction, a of x. That's simply the time derivative of the x part of the velocity vector, v sub x. So this is going to be equal to, there's no time component of alpha, so it's just going to be equal to minus, the 2 comes down front, 2 beta times time. And then lastly, let's rebox that in so we're not blocking out part of the solution. Lastly, we just need to find the acceleration in the y direction, a sub y. That's going to be equal to the time derivative of v sub y, which is just gamma t. So the time derivative is just going to be equal to gamma. Okay, so now for part B, we are asked to find the bird's coordinate, the y coordinate, as it flies over x equals 0 for the first time after t equals 0. So it flies away from t equals 0 at from the origin at t equals 0, begins to fly, and eventually will cross back over x equals 0 again. So first we need to find the time it takes to get there, and then using that time, we can plug it in and find the position, the y position. So first, to find the time at x equals 0, well, x is equal to alpha times time minus 1/3 beta times time squared. Well, since it's equal to 0, we can cancel some of those times, or excuse me, not times time squared. That was times time to the third. Let's rewrite that. 1/3 times beta times time to the third. So getting rid of some of the times, we have time squared. So solving for time here, time is equal to the square root of 3 times alpha divided by beta. Plugging in our values for alpha and beta, we find that this is equal to 2.12 seconds. Okay, so now plugging in that value for time into our equation for y, which we found to be 1/2 gamma t squared, as well as our value for gamma, we find that y is equal to 9 meters. We can box that in as our solution for part B.